right, guys, welcome to Module 2. We're studying coordinate geometry. That means we're going to be looking at shapes and points plotted on a graph and finding information about those points, such as the distance between them, the midpoint between them, and also how to find the equation of a circle that passes through those 2 points. So all of this has a pre-skill though, and that pre-skill is simplifying radicals. So we're going to work first on that. So a radical is the inverse operation for an exponent. So square root is the inverse operation for square, cube root is the inverse operation for cube, fourth root is the inverse operation for fourth power, okay? So the only thing we need to know in order to simplify radicals are 2 things. We need to know that the inverse operation for square is square root and vice versa. And then we also need to know that I can break up a radical around multiplication. Combining those 2 skills, we can take a radical like this first example, square root of 200, and we can write it more simply. So to simplify a radical like 200, the first thing that we would do is make a factor tree to start to break this down into prime factors. To find prime factors, I just divide by the first prime number that I see that goes into or that evenly divides the number I'm starting with. So for me, the first prime number I see is 2 times 100. Or at least 2 divides 200 to equal 100. So 2 times 100 is 200. Now I'm going to break down my 100. I could do 10 times 10, or I could do 50 times 50, or 50 times 2. So I'm going to choose 10 times 10 because the whole purpose of this is to identify square factors. That is repeated factors that occur in our starting number. Since 10 and 10 is a square factor, 10 times 10 is 10 to the power of 2. I can go ahead and stop here. I don't have to break it down any further because I now have all of the numbers that multiply to be 200 written as either prime factors or square factors. So here's how we go ahead and do this. Square root of 200 can be written, let's tidy that up a bit. Square root of 200 can be written as square root of 2 times 10 times 10. I'm now going to split my radical around multiplication. What I want to do is look for groups of square factors. That's 10 times 10, that's my square factor, so this is where I'm going to split my radical. Square root of 2 cannot be simplified, but it's being multiplied by square root of 10 squared. Since square undoes square root and vice versa, the square root of 10 squared is just 10. Square root of 100 is 10. So this is square root of 2 times 10, which we can rearrange with the commutative property of multiplication to get 10 square root of 2 as our simplified radical. So when I see square root of 200, Lumen is going to want you to enter this as 10 square root of 2. And it's not just Lumen, it's best practice in math. The other example I have here is square root of 6,125 divided by 2. In order to simplify this radical, I'm going to do the same thing. 2 is prime already, so I'm going to focus on my 6,125. I'll write it down here to give myself some extra space. And I'm going to make a factor tree. Now, I do not know all of the prime factors of 6,125, but I do know that it's divisible by 5, and that's because any number that ends in 5 or 0 is divisible by 5. So I'm going to start to divide by 5. 6,125 divided by 5 is 1,225. That number also ends in 5, so I'm going to divide it again. If I do 1,225 divided by 5, I get 245. Also ends in 5, so I'm going to repeat the process. 245 divided by 5 is equal to 49. So 5 times 49 is 245. And now I know 49 is a prime factor. It's 7 times 7. So I am going to rewrite my fraction as the square root of 5 times 5 times 5 times 7 times 7 all over 2. I can't simplify this at all because there's no common factors in the numerator and denominator. So my next move is going to be to split my radical around division so that I get square root of 5 times 5 times 5 times 7 times 7 all over square root of 2. And now I'm going to split up my radical around multiplication. I'm going to look for square factors. That's factors that occur 2 times in a row. Every time I have 2 factors, that's where I'm going to split my radical. So this could be further reduced as square root of 5 times square root of 5 squared times square root of 7 squared, all over square root of 2. Every time I have the square root of a square factor, square cancels square root. And I'm left with the number under the radical. So this could be written as square root of 5 times 7, all over square root of 2, also known as 35 square root of 5 over square root of 2. Now we're almost close to done. There's no more radicals that I can simplify, but we do have a rule that we need to rationalize the denominator. I can't divide a number by an infinite number of parts, and square root of 2 is an infinite decimal that goes on forever and never repeats. I can only divide by a whole number, or by the number. I can divide by a whole number or a negative whole number, an integer, but I can't divide. I can even divide by a rational number, like a fraction, but I can't divide by an infinite number. So instead, I'm going to use a little trick called rationalizing the denominator, and I'm going to recognize that if I had had square root of 2 squared, that would have canceled out my radical. So I am going to multiply by what I need to make this square root of 2 squared. So I'm missing another square root of 2, but I can't just multiply by, or I can't just divide by square root of 2. I need to multiply by a fancy form of 1 so that I don't change the value of this fraction. When I do that, this is the same as 35 times the square root of 5 times 2 over the square root of 2 times 2. 35 times the square root of 10 over 2, since the square root of 2 squared is the square root of 4, which is just 2. So my final answer is 35 square root of 10 divided by 2.